My name is Sean Blakely, and this is my Physics 131 Week 4 summary. On Tuesday, February 9th, we picked up where we left off last week, exploring electric fields. This is a picture of the activity that David had us do that allowed us to see the relationship between protons and electrons and the nature in which they attract and repel. Okay, so this next, I'm trying to pull it up. Let's see. So the next thing we did was we continued our exploration in PhET, which is a simulation for allowing us to see the electric fields of positive and negative charges and how they interact. Okay, so next, this is a picture of the board where David has derived an equation that allowed us to calculate the distance between two charges. And then on the left side of the board, we were asked to solve for that value of x right here using the equation that we derived on this. So after that, we moved back into Arduino boards, and we were assigned the light theremin to build. And this was a really cool project. So we have a picture of it here. And pretty much we created a piezo, is what they call it, that when we hover our finger above this little piece, it senses how far away your hand is, and it changes the frequencies emitted by this piece here, which is really cool. It made a really weird noise, but I found the entire process pretty cool to begin with. So David explained that he was going to have us do a project with this piece. So we're going to do a presentation. We're going to create a screencast that included an overview, hardware, our build, our extension, special devices, and a conclusion. And kind of in the same fashion I'm doing now, same type of deal with the screencast. And there's actually two. We didn't start the other one until next Thursday. Moving on to Thursday the 11th, we started class by watching a pretty cool video that Einstein had made a prediction that had actually been proved now. The video pretty much went through gravitational waves that can be detected using some pretty cool stuff. So then we moved into spiral electric fields. David had us print out this packet. We brought it to class and kind of went through it. We explored more within the PhET, just kind of a deeper level at this point compared to what we did last week. Let's see, we have I tried to pull up the packet, but for some reason it's saying it's not there anymore, so I'm not going to be able to show you that. But what we have here is our PhET simulation. We drew the net charges on, when we have several charges here, we had several points where we wanted to, see what the net charge would look like between these charges, just depending on where they're located at. We did this through vector addition pretty much, depending on the force of the charge, the magnitude, the direction of the charge of both of these charges acting on a certain point would result in the purple vector we have shown here, which just shows the net force. Same thing on this side. So we drew those first, and then we came to PhET to check our predictions that we made, which was on the whiteboard. And it was pretty much, it matched up with exactly what we had here, which makes sense due to the vector addition and the force of each of these charges and knowing how they interact. You can definitely see how this works. So with that, we moved into the next piece of the packet, which we explored what the charges would look like and how their magnitude vectors would be drawn and the way they're pointed with several of them clumped together. As you see here, we have 2a and negative 4a. And for example, the 8a, a positive is going to repel, and these are going to be longer, much longer than, say, only 2a. Same thing for negative 2a. You're going to have, it's just pretty much going to double the attraction, which has been pretty consistent with what we've been learning. The last thing in the packet that we went through was pretty much what we kind of did last week, just exploring hypothetical, questions, saying if you're going to bring a positive charged rod to, neutrally charged globes, in several different situations, and we met as a group after we came to each of our conclusions to discuss this, and everyone pretty much was saying the same thing, had the same type of answers. Okay, so after this, we moved back into Arduino boards, continuing our projects from Tuesday, and we were assigned another one, and this time it was the crystal ball. Number 11, the crystal ball, and this was a pretty complicated circuit compared to what we've been working with in the past, and just reading this initially, I was like, okay, I wonder how this is going to work. This must be pretty complicated, because we're going to create a crystal ball, pretty much like a magic 8-ball that's going to tell the future, Okay, so here's the circuit. We attempted to build it based off the schematic. I still need some work on that. We were kind of lost on that piece, so we went through to the diagram. Initially, we couldn't get it to work. After David showed us a couple things, we got it to display correctly. So here's what we have, which is really cool. The way it worked was that you would disconnect one end of this piece. I mean, after you ask your question, of course, disconnect one end of this piece, and then you would get you plug it back in, and you'd get an answer. The ball says most likely, so you'd ask it a question and you'd get an answer back, which is really cool. So yeah, as we have here, we finished Thursday's class on that note, and so now I'm going to move into our modules that we were assigned for this week. Let's go ahead and move down here. Okay, so we started the week out which was with a movie, which I thought was pretty cool. It was a pretty long movie, but it was really good. I enjoyed watching it. I found it pretty depressing and sad, actually, but it did open my eyes to a lot of things that I was unaware of. Just our normal discussion here that we kind of went through. I think I had a lot to say about this one. Yeah. The lottery was really shocking. Sad, very sad. So we moved on to, after this, we had, let's see. Okay. So we had a neat resource, programming. Just pretty much, citing a pretty cool, any cool resource. Maybe an article. I think I had an article here. Yep. I stated that programming is useful to solve many potential problems, and it can create a lot of things. So next we move into hacker spaces, maker spaces, and digital fab labs. This was another neat resource. I was kind of unaware what these terms meant. They're actually like community. They're like community groups, with people that share similar interests and can get together and work on, people. I think hacker spaces has to do with computers and things like that. Maker spaces is 3D printing and things of that nature. which is really cool. I found a one in Tucson. To actually go to their link. This is their link. They have a lot of really cool stuff on here, and they have a pretty big space that they get together and build stuff. So thought that was cool. So VPython. I worked with VPython in Physics 121. So a lot of this stuff was pretty familiar to me, although we did take it further this time. So the assignment was this. So we pretty much had to go through all 9 lessons, which we just explored VPython, made several different things. I was pretty familiar with it because we did work with it in Physics 121. So yeah, let's go ahead and move to show you a little bit of that stuff. It is right. Let's see. Okay, I found it. It's here. We have all of our lessons I've completed. One of the really cool ones was I found them all pretty cool. So let's just show you one of these. For example, this is the constant momentum model. Let's see something we can run. I'm not going to attempt to run one of the more difficult ones just because I'm not sure if it'll do it, but let's see if it'll show up on the screencast. So we're running the module now. Might take a minute. Here we go. Okay, so as you can see there, we had all 4 balls coming together and separating. So that was number 4. That's just an example of showing you what it does. Okay, so that wrapped up VPython, and as you can see here, we have a video that actually taught me how to create this screencast I'm doing right now. We have the spiral electric fields, which we went over in class on Thursday. Our presentation for our 2 projects that we did on the Arduino boards, we're gonna turn that in. It's gonna be the same type of deal we have here with the screencast. We have our topics that we're going to include in that. So that's it. That was pretty much the week 4 summary. That's pretty much everything we did in class this week. I think total we always have about 6 hours in class. Out of class, I've worked on it about an hour or 2 every day. Today was actually much longer. To actually create the screencast and get everything set up was about 4 hours. So total on the week, I'm at about 11 hours. Yeah, it's going to wrap it up. Thanks.